Hello. Good afternoon. Hope everybody had a good lunch. I'm Ian Willoughby, and I'm with Second Watch, and I'm joined with two of my colleagues here. We got Lars and we got Travis. You can see our spellings of our names up here, but we're all with Second Watch, and what we're going to do today is talk about some of the proven methodologies that we've seen with our enterprise customers in order to accelerate the journey to the cloud. And of course, we're going to give you a lot more detail on that as well. So just a quick highlight of the agenda that we're going to talk about here. But before we can talk about accelerating the journey to the cloud, what we need to talk about is what a typical journey looks like. And so we're going to spend a few minutes on that. And then we're going to spend some time on 5 of the challenges, the main challenges that we see out there, and some of the solutions associated with that in order to get past those and really enjoy a great journey, a transformational journey. Then we'll talk about sustainability as making sure that you can maintain that great state on your journey to the cloud beyond just getting there, and then what that future outlook is as well. At the end, we're also going to give you a demonstration of some of the things that we talk about as well that play right into some of these different methodologies. So with that, quick overview. This is what a typical journey looks like. There's a lot of excitement at the beginning, then you hit an inflection point, things slow down, and then hopefully you get the speed back up. But with that, we'll go through some of the different phases. Early on, you've got a POC phase, and that is going to be when everybody's excited. You're trying some new things. Probably somebody put a credit card down on an Amazon account. Tried out a few things, and it's really exciting. I remember my first EC2 launch. It was a lot of fun. It took minutes. It was awesome. I'm sure everybody remembers that feeling about how amazing the cloud was when you saw that. Second phase you get into, you get a little bit further down the line, and this is when things start to become a little more serious. You've gotten through the POC, things have worked pretty well, but there's more eyes getting on these types of things. And so a lot of cases too is that your POC was no longer a POC, it became production somehow as well. Temporary is always permanent, as we know in IT. So this is when your IT organization starts realizing that the cloud is real, and you're going to start having to look at a few additional things: speed, accuracy, and then management's getting involved. People are starting to get comfortable, and then you start getting the questions like, how much is this going to cost? Who's going to be in charge? What is our strategy? Or do we have any standards associated with those types of things? And then that's when things start to slow down. This is when people like your risk management get involved. The questions are asked about standards, security, governance. Things really start to slow down. There's lots of meetings. We love meetings, right? That's when you get all the work done. And then you start to develop a cloud-first strategy. And that's really when you start coming up with the rules and the standards of how you're going to do things. When are you going to use RDS? Where are you going to do it on EC2? Those types of questions are starting to be answered. And then a lot of holes get poked into things. Your aspirations may slow down a little bit, and that's okay. That's okay. Your risk management people are getting involved too. Their intentions are good. We know that. So this is when you realize that you really need these policies in place. You develop these policies, and now you've got governance, you've got solid foundation. You're starting to use automation as well to really enable accuracy and speed. And you've prepared the environments and everything around it for the operational aspects of it going live and being supported in the future. But at the same time, it's important to realize that you still want to keep that experimentation model, that culture that where you were with the POC. And you don't want to lose sight of that. And you don't want to sacrifice security at any of these stages as well, because nobody likes to be on the Wall Street Journal article for the wrong reasons. So imagine that. You get through some of these things, and what we're going to talk about is trying to make the acceleration look more like this, a little bit more of a smooth curve. And we've worked with a lot of clients out there, a lot of enterprises, and that's the story that we want to share with you. So what are some of these challenges and solutions? We have about 5 main ones that we've identified that we want to talk about today. There's more, of course, but these are the big ones. And we're going to talk about secure, sustainability, and maintaining agility as well. So here's a quick highlight of them. Lack of knowledge, unknown state of what you have currently, no guardrails, reduced speed and accuracy, roadblocks from risk management. So dive in a little bit more on each one of these. So lack of knowledge and experience. We've got issues, right? You're starting out, we've got a lot of questions, there's a lot of unknowns. Who has the skills? How are you going to get these skills? These are all the types of things that people are asking. Well, the solution is, there's a lot of things. There's not just one thing. But this is really a behavioral type of issue as well. So you have to start looking at how you're going to handle this. So it starts at the top. You've got to have IT executives leading from the front. They've got to be able to articulate the value of the cloud. They've got to understand the work that gets put into it, and then really be able to communicate that both and up and down the management chain. So that's very first and foremost. The second part is that you want to create a cloud center of excellence. Now, that's a fancy word or fancy phrase, of course, but it's usually a small group of people. It's cross-functional. It could be engineers, DBAs, management as well. It could be finance. You know, there's no right or wrong way of doing it, but you need to have stakeholders involved in this, and they're really going to be the leaders of driving this transformational change. Part of the mission is also to make sure they educate the staff. You don't have to educate everybody to start off with. There's great tools out there, of course. There's training classes. There's certifications. In a lot of cases, a lot of our clients and partners, they offer bonuses to people to get those certifications because it demonstrates that you can put the time in, you can learn it, and the AWS certifications are certainly well worth the effort. So now you've got some staff education, you've got some knowledge and leadership, you're developing a cloud-first strategy, and that's really where the tipping point's going to come into play here. And those are going to be the guiding principles in order to keep this journey alive. It's a living document. It doesn't have to be all done in one time. That's a mistake a lot of people make. You start small, you continue to enhance upon it, and that's going to be very critical. And last is, in a lot of cases, you can develop KPIs around these types of things. KPIs can be SLAs to get deployments done. They can be cost metrics, a lot of other types of things as well. So there's no right or wrong answers there, but it's great to be able to measure things. That way they can get managed. Okay, next challenge that we see is, everybody's been in their data center, right? At some point, you've got a lot of things out there. But what do you have? Half the time, you don't know. Anybody still running Windows 2003? Yeah, exactly. Exactly. I bet that system's well documented. But don't be afraid. You're not alone. Virtually everybody that we run into is in the same situation, and it's not the end of the world. It's a little bit challenges, but you wouldn't get paid the big bucks without it, right? So the other thing is, too, is that you don't necessarily always know what your on-prem situation looks like. Most cases, you've come from a very traditional IT environment. Everything's over-provisioned because nobody wants to have to reorder another set of servers or VMs on-prem. It's a pain. It takes too long. So it's just easier to kind of say, I'll take the next size up. I'll get a little bigger, and those types of things. So you've really got to kind of understand that too. So there's a lot of different ways that you can have to look at those types of things. We'll get into that as well. But there's also a lot of undocumented applications out there as well. Sometimes you find applications that are running under somebody's desk. You got to move that to the cloud. You got to get that out of there. That's not going to be sustainable. But I do come bearing good news. It's now the time to unwind your technical debt, and you can do so. So, solutions around this, it's really going to be what we call a readiness assessment, essentially. You're going to come in, you're going to analyze your existing workloads. There's a lot of tools out there. I won't go through the whole list, but you put these in place, they watch your network traffic, they look at the RAM, they look at the CPU utilization. You start to uncover the interdependencies of your different applications. This knowledge is paramount. But that alone, what gets put out by these tools, is a great start. But it also takes the human aspect. You got to go out and you got to interview the application owners and understand what's driving them and what's important to them as well, because there's always nuance to all these. Once you get through that, you want to assign the risk level to each of these types of applications, because that's going to be very critical in understanding how and when you're going to migrate these types of applications, these workloads to the cloud. And then you're going to produce a full assessment report. And this needs to be shared to everybody because you need buy-in You need understanding. And that's going to rate the dependencies, what you need as far as provisioning sizes, resources needed. And it's also going to uncover things like security traffic or network security traffic. What ports do you really need open and those types of things? Because, again, security is very important. And then ultimately, once you get through that report, you share the information, you're going to be able to develop a workload migration schedule and a plan that's very detailed. And that's going to be how you ultimately execute. So, in the end, you'll probably know more about your workloads than you ever have. And that's great. You're going to capture that information. It becomes a great artifact. Next issue is that there's been articles out there. What happens when you don't put any guardrails in place? Well, things can go off the rails pretty quickly. Usually not right away. It happens later on. You might create some S3 buckets that inadvertently somebody temporarily turned on public access to. Well, it ends up, it has PII data in it. And the next thing you know, you're having to do a disclosure to everybody that your data was compromised. So you want to avoid those situations up front. And let's talk about some of the ways of doing that. So you need to create a cloud security policy. So how do you go about doing that? Several different ways. Typically, a lot of our customers, they may have PCI compliance issues, HIPAA, NIST 853. It just depends on the industry. Sometimes some of our customers that are very large, they have multiple compliance frameworks that they must follow. And then, of course, you have corporate governance as well. You may have things about data retention or other security types of things that you need to factor in. And then if you're at a loss and you don't quite know how to get going with this, there's a lot of great resources out there like CIS. They have benchmarks for the cloud and a lot of other things as well. So that's a great starting point as well. You take these together, you mix them up, and you're going to create your own policy. And if you don't have a policy, that's going to be a problem down the road. But this policy fits back into your cloud-first strategy as well. With that, you start developing a very solid foundation once you have these policies in place. You're going to create a landing zone. You've probably heard that term before. There's actually an AWS product called the landing zone. But essentially what that is, it's a culmination of a lot of different things. It's an account strategy. There's no right or wrong reason behind account strategies. I'm here to tell you that. Don't spend a lot of time trying to figure out how everybody else did it. But typically, you're going to want to segment things into accounts. That could be done by production, non-production, or it could be done by business unit. There's a lot of different ways of doing it, and no organization is the same. But ultimately, you want to design those foundational components and into your landing zone. And those are going to be things like security. Tagging standards are critical. Critical, critical, critical. Start with your tagging strategy early on. You'll thank yourself later on. You'll hate yourself if you don't do it. I can tell you that. And I think a lot of people can attest to that. This is where your reference architectures also get developed too. So you're going to find the typical patterns that you are launching out there of the different types of stacks and application workloads. Again, you're probably not going to be able to develop a reference architecture for every single one of them, but most likely 80% of your workloads may fall into 10 or less reference architectures. And that is a great place to have that documented and understood. And then ultimately you have shared services, of course. That could be Active Directory, that could be your egress, security stacks, you name it. There's all kinds of things that you can put in there, and you need to be able to share those amongst all the accounts and different VPCs. And then, of course, configuration management. If you're dealing with particularly legacy applications that are kind of monolithic, you have to have this in place as well, because this is going to ensure that every operating system and the various components and agents that get installed are going to be out there. Then it also works great for compliance because it gives you an audit log of differentials. So that gives you guardrails. Keeps you off the naughty list. Okay. Reduce speed and accuracy in deployment. So this is what happens when suddenly you're dealing with hundreds or thousands of workloads and there's pressure now. It's cloud. Cloud is fast. How are you going to get there? Well, you're not going to do this in the console. I mean, I love the console, don't get me wrong. But this is not how you deploy thousands of workloads. You just won't get it right. There's going to be lots of errors. There's going to be a lot of rework. You're going to forget things. There's security holes, all those types of things. You're going to want to do this with automation and using those reference architectures that you've already developed. So this is where a pipeline comes in, a deployment pipeline. You're going to be able to develop those reference architectures. You're going to want to check them in, infrastructure as code, into repositories. You're going to want to version these things. And it doesn't matter if it's CloudFormation or Terraform. There's no right or wrong answer there. In fact, it could be a mix if necessary. But ultimately, you're going to need a way to author those templates, check them in into a repository, and maintain versioning. And then you're going to have a system that takes these reference architectures, takes the parameters that you need for each type of workload, combines them together, and then you're going to execute it through a type of build platform. And again, it could be a variety of things. Code build is a fantastic one, of course. It's native to AWS. But again, it doesn't have to be. It can be anything that you need it to be or what you're comfortable with, but you need to do it this way. In taking those values in, it doesn't matter if it's a text file, a web application that you build, or an Excel file. As long as it all plugs into the pipeline, it's going to be fantastic. Now, at the end, you may want to take these reference architectures in this build pattern and put it into Service Catalog. This is going to allow you to take it to the next level of self-service, because now you've got all the guardrails, you've got all the reference architectures, you've got all the rules that you need into the platform to ensure that things get deployed by anybody in your organization correctly and within all your governance and security models. All right. Next one, roadblocks from risk management. Happens, right? On occasion, somebody says, whoa, what are you doing? It's risky. So that definitely happens. What we're trying to do here is to take the Department of No, which we'll spell it N-O, and make it into the Department of Know, K-N-O-W. And how do you do that? Well, that goes back to the staff education and making sure that they're included early on in the process. It's very critical there. But what they really need is visibility. That's the driving factor. They need confidence that the data and everything out there is accurate. So this is when you have a set of tools. There's a lot of different ways to provide these types of visibilities. Here's some of the tools. CloudTrail is a great one. AWS Config for your change management. CloudWatch is your friend, of course. You can use it for logging of many, many different types of things. And it also makes it easy to ingest into other platforms, such as Splunk, or other types of visualization tools as well. And that's critical as well, because then you can start, when you see change happen, you can signal on it, and you can take action, and you can understand why and who and when that was accomplished. And then, of course, IAM roles and federation. I hope everybody has those root credentials locked away very safely, out of place for no one to access unless there's a glass break incident. So this is where you want to take your single sign-on with a single identity store, most likely Active Directory, and you're going to build roles associated with those into your organization so that the right people have access to the right things and not the wrong things. But you should give them the power, because now you've educated them, so the things that they work on, you should give them the proper authority and authorizations to work on. All right, so with that, what do you do after the migration? I'm going to hand it off to Lars.
All right.
Yeah.
I swear I'm a technical person. I know how to work a clicker, I promise. Yeah. So you got to AWS Cloud, now what, right? I think this is probably the most common thing. So all those things that Ian just talked about are super, super important, but how do we make the most of new technologies available to us in the cloud? As a customer specifically, I want to know a couple of things. First, I want to know about cost and how it changes over time. Are all my security practices that I brought with me from the data center still valid? And these are things that you don't even really think about it, but those are actually even before you get to the migration, those are things that you need to start thinking about. And so when we talk about transforming to cloud native, one of these things that we look at, right, is something that I don't know if everybody knows who Werner Vogels is. I hope you do. He'll be speaking at some point during this conference. But he loves referencing this paper by Nicholas Carr in 2003. It's called a paper called IT Doesn't Matter. And what he means really is that there's a certain amount of IT that everyone has to do just to run your business. And as such, because everybody going to the cloud, that's no longer your differentiator. That's not a competitive advantage just being on the cloud anymore. Once you get there, we've talked everything about infrastructure, about your foundation, but how do you actually start changing things to make it go fast? right? And so when we do that, we talk about tools, practices, engineering culture becomes hugely important. That becomes your differentiator, how you actually interact with those resources and how you refactor your applications to make use of them. And so we basically, at this point, what you want to do is minimize the challenges of shipping and rapidly iterating and securing software applications. There's a great quote from, and I love quotes, by the way. Lori Worster, the research director at Gartner, says, digital business is essentially software, which means that organizations that expect to thrive in a digital environment must have an improved competency in software delivery. So we believe at the core of it, this right here is what DevOps is when you like kind of distill it into an objective. So how do we at Second Watch propose doing this? We believe in building the systems necessary and working with teams to support higher level architectures. The adoption of service-oriented architectures and microservices while migrating away from monolithic application design. Now, that doesn't mean you should just use microservices because people say it's great and it's cool, but like it does solve some really interesting problems. And so some of the things that we talk about is even before you get to the part of like where you have microservices or service-oriented architectures, you have to have this journey to immutable infrastructure. And what that really is this way to managing services and software applications and deployments on IT resources wherein components are replaced rather than changed. So if you have a hot fix or a hot patch or something like that that you need to work on, you don't go right into production, start coding and be like, all right, cool, I got it, we're ready to go. That never ends up in your lesser environments. And so then when you start shipping code, what happens? This is obviously a rhetorical question because I have the mic, but it's going to break. You're going to have an outage. Something's going to happen. It's never going to end up back into production, right? And so how do we make sure that those changes occur? So practicing immutable infrastructure is essentially that idea that whenever I need to make a change, if it's an operating system patch, a software patch, any of those things, I am creating a new deployment. And one of the reasons why that's so important is because the prerequisite to mastery is practice. Right? The more you deploy, the better you are at it. The less you deploy, the harder it is. And this is why people talk about decreasing batch size and all these things that we know from like lean management and lean and agile and all these things. That's just told us over and over and over again, right? So when we start talking about this journey to immutable infrastructure, what does that really mean, right? When we start talking about like replacing rather than just fixing or any of those things, what we're talking about is essentially getting good at shipping software. Practicing it over and over again. And some of the byproducts of this are things like impacting your mean time to recovery. If you're just replacing rather than trying to fix something on the fly, you're always going to be faster. And that's just a byproduct of practicing this. It's not going to solve all your problems, but that is something that immediately is a true gain. You also gain improvements in scalability as a byproduct, right? You're offloading session management from your individual instance to a cluster, something outside of it, and treating it as a backing resource. Now you can scale horizontally rather than just vertically, right? And so this enables like things like auto-scaling groups and launch configurations, launch templates, all of these things, right? That we've kind of been around for a while, but we don't really make use of in the data center because it's hard. So by doing something like this, we increase scalability, resilience, performance, security, right? You have, we'll see a little bit later, kind of a use case for immutable infrastructure where you have a security incident and you have a compromised instance and you just pull it out of the auto-scaling group, right? You quarantine it, and now you can do all of your investigation on it whenever you want at your own leisure. But now you can rest assured that production is no longer compromised. So immutable infrastructure kind of goes hand in hand with the well-architected framework from AWS, and so that's one of the reasons why we like it so much. But some of the other things is that it kind of enables an even bigger transformation. Right? And so when we talk about this journey to immutable infrastructure, we talk about going from service-oriented architectures to microservices. One of the things that we look at is like the deployment pipeline and the path to production of your application. This is not an easy task. So many times this involves changes in the actual application code to make use of this deployment pattern. Right? Like I mentioned, offloading session management out of your application to a backing store or something like that. Right? But many times this involves those changes to the application and your deployment pattern. You can check out 12factor.net if you haven't seen it before. It's a really great practice written by the great folks over at Heroku. But we've talked about VMs to containers to functions. And so as you start decomposing your application, developers can begin looking at the application and break off segments in what we call bounded context, right? So what you want to do is you want to create services that have specific limits on their concerns, right? And so a good example of this is well, one, by show of hands, how many people have bought something on Amazon.com in the past like 3 days? Yeah, right? That buy button is a great example of a single concern service. The only service that performs is to kick off a buying pattern. That's it. So how many bugs can you have in that? A lot less, right? You don't have to worry about all these corner cases of all these other things happening. I just need to send this transaction to this service. That's it, right? And so when we talk about this, there's a couple of things that kind of become really interesting about it. As the architecture becomes more granular, the deployable unit shrinks, decreasing your batch size, resulting in more frequent deployments with less lead time. Right? And so that increased competency in software delivery becomes more and more important as you begin shifting from right to left. Oops. So what I'm talking about is trading in your complexity. So in this approach that we're talking about, infrastructure and application development as a workload becomes more fine-grained. As your deployable unit becomes smaller, right? So you go from a VM to a container to a function, what you're really doing is trading your complexity. You're trading code complexity for operational complexity. And the reason why we do that is because operational complexity has a way of being managed in an automated way for the majority of the tasks and issues that we run into day to day, particularly when practicing the idea of immutable infrastructure, right? If we just need to like replace our infrastructure, replace those instances, replace the container, redeploy our function, we can do that a lot faster. Second, the reliance on the tools becomes greater, and this must not be overlooked. This is like the biggest thing. So we evolve our architecture, we say, hey, we're gonna go to microservices. We're gonna go functions as a service, right? But none of our tools that support our applications ever change. But we have increased reliance on them because that's what's visualizing our entire system. Has anyone ever seen what like an architecture diagram looks like for like Amazon or Netflix or anything like that? Spoiler alert, it looks like a Death Star. Like you can't even see all the individual components because they're blocked out because they're so tiny, right? But how do you visualize that system? That's where your tools become super, super important, and you have to rely on them to see what's happening in your system. So increased visibility, supportability, all those things become a matter, like a function of your tool set, and we become so reliant on them. So what kind of capabilities are we talking about with this, right? One of these things is like service mesh. It's a new term out there. A lot of people are talking about it, but what does it really mean? We'll talk about that in a second. Service discovery, right? How do I know what the payment service is that I need to talk to from my cart? How do I know that those two talk to each other, right? How can I identify them? Log aggregation. Where do my logs end up? If I'm constantly replacing my instances or my functions, where does all that information get stored, right? So we talked about CloudWatch, CloudTrail, things like that. That's where we need to start thinking about. That's our window into our system. Configuration management. Ian talked about that a little bit, but what does that really mean when you get smaller and smaller? When you go from containers to functions, what does configuration management really look like? And so you have lightweight and centralized versions of configuration management, where I would say something like a Puppet, Chef, Ansible are more of like the centralized. I know Ansible's not really centralized, but follow me here. Basically, the idea is though that you have all of these like playbooks, you have plans, you have recipes, you have all of these things that are required just to manage your application. As your deployable unit gets smaller and smaller, a lot of those things start going away because you have less concerns to manage. It becomes actual less code that you're writing. The code that you're writing is actual business value that's being delivered. And then we have metrics and outlier identification. And so that's like another really big one. Like when you have so many services, say you have 1,000 services, how do you identify when they're performing well and when they're not performing well? There was an ad recently I just saw on one of the slides before we started talking from Signal Effects. One of the things they boast is about outlier identification. So if you see patterns in your metrics that aren't really jiving well with what traditional use is, you can ID those really quickly. And so with service mesh, the other thing is we talk about security, right? We talk about north-south security a lot of times, like what's going in and out of the data center. When you have microservices, what's the other kind that you have to think about, right? East-west. Service-to-service communication. How do I know that that service that's talking to this one is actually who they say they are, right? And so this is like service mesh is like you need mutually transparent TLS trust connections, so you can have secure transit all the way throughout. So even further down the road, right? So I mentioned log aggregation. So I'm going to pull out a crystal ball real quick, and I'm going to say kind of where I think everything's going. And this is a little off topic for this, but I think the thing that we're going to find out is, so all that log data that we're aggregating right now, we don't make use of it. It's completely commoditized. It gets thrown away. We have like a nice life cycle policy that kind of functions and kind of moves it out so we're not using up so many resources. But what else could that provide us? So like, we talk about operational metrics and things like that. I think what's going to eventually happen is we're going to start beginning to get higher levels of visibility into what our business is doing by looking at the applications that are running and the interactions that we see our users having with that. Now that's not new. That's like, people have talked about that for a while. But I think that we're going to start with the tools that are coming out now. It's going to make it easier. Things like SageMaker, things like Athena, things like that, make it easy to query that information to get actionable results. Operational metrics are almost the same across any type of infrastructure you run, across any application. But business analytics and business intelligence are things that come from a practice. And if you're not building one of those like kind of learning organizations today, you're going to be losing the one in the very near future. People that are learning from their data, learning from their applications are going to be winning in the marketplace faster than anyone else. So if you haven't started building a data practice, I highly suggest do it today. And with that, I'm going to turn it over to Travis.
All right, so speaking of all of that data that's generated that we don't do much with, this is going to be kind of a showcase of how we can take that data and stand on the shoulders of giants in a sense. So Lars mentioned Athena and other queryable services. Something that we think is very valuable is Amazon GuardDuty, which allows us to take some of that data, leverage their findings, and apply those findings via event-driven notifications and functions to our own environment. So let's take a typical customer scenario. So, a customer might have all the log boxes checked. There, you've got your CloudTrail, you've got your VPC flow logs, you have all of the ELB logs, etc. All of these are being captured. All of these are being sent to S3, and we as engineers or your operations team or anybody can go in there and after the fact identify what's happened. Maybe an application's crash, maybe at a security breach, something caused you to go in there and evaluate those logs. And certainly you might have the analysis, alerting, all those kinds of things. But that's the common pattern that we see, especially with companies that are starting to move to the cloud, are that their old tools still reside in the data center and they haven't necessarily moved those to their cloud environment yet, or have fully leveraged kind of the capabilities that are available. So if we see a customer with a let's say a standard cloud deployment, oftentimes the challenge that they have are there are these multiple data streams, tons and tons of log sources. They're being aggregated maybe into a centralized platform, but oftentimes that isn't providing a ton of value. And furthermore, they don't necessarily have the operational expertise or bandwidth to take advantage of or to react to these events in any sort of, I guess, quick or meaningful way. So I mentioned some of the tools that AWS has. GuardDuty is one of those that I think is very powerful, and is something that allows us to take those all those data streams and make judgments against what's in there. So most of the people in here, I'm guessing, have seen the output from CloudTrail, from CloudWatch. You might have set up some SNS notifications. You get emailed when a certain threshold has been breached. But whenever I look at my email, it's hard to read. It's kind of crunched into my phone, and I can barely even make out what exactly that event is. I have to kind of scroll down to parse it. It's hard for me to quickly classify what I'm looking at and whether that's even valuable or a false positive. So GuardDuty does some of that analysis for me, but even GuardDuty's general, I guess, notifications are a bit cryptic and hard to read out of the box. So I mentioned, here's a GuardDuty alert notification that, was sent to my email. I don't know exactly what that says offhand. I probably have to get up close and read it. But, you can get there. You can parse it out and see, oh, yeah, this instance, okay, I'll correlate that to a certain server. And, okay, in this farm of auto-scaling nodes. And, okay, yeah, I see what it's talking about. It mentions, it's talking to a known command and control Bitcoin mining server. So It's not exactly easy to pull that out, and if I'm getting a lot of emails, I might actually miss that and miscategorize it as a false positive, and to be honest, I might eventually just create a folder in my email that filters those, and I might look at them nightly and see if anything bad has happened in my environment. So how can we go from just capturing that data and setting some simple alerts to actually centralizing it and putting it into putting some visualization and analysis around that? So AWS has a very nice Elasticsearch kind of Kibana bundle. They have a quick start available. You can go ahead and take a look or search for it under, I'll have a link here in another slide, but that will capture VPC flow logs, CloudTrail data, et cetera, index all of that in Elasticsearch, and then visualize that in Kibana. So I can actually go to a kind of single dashboard to see all event or log data in my environment surfaced in some sort of meaningful way. So you can see that it's you know, if I look at the example here on the slide, you know, I see that that instance that's querying the Bitcoin command and control server. Okay, it's nicely organized. It's showing me the instance, etc. This is the kind of flow of that. You can probably replace CloudTrail, etc. on the left with VPC flow logs or any sort of other log data source, and that's actually what GuardDuty is responding to in the previous slide. So the quick start template that we use for this is called Visualizing Amazon GuardDuty Findings. It's just a AWS hosted quick start that was published maybe a year ago. But it's very valuable, and it's something that when many customers come to us for either their kind of first start in the cloud, or they're looking for a service that's going to help their operations team just make sense of what's in the cloud and all those data streams that are coming at them, this is an extremely useful tool. So it allows me to take all of that, visualize it, and provide some meaningful context and findings. Now, let's say I went to go and investigate that instance that was communicating with the Bitcoin miner, but it's already terminated, it looks like. So you can certainly capture the data. I think that's all step one. Visualize the data and analyze that, and you can achieve that with Elasticsearch, Kibana, or any other centralized log and analysis platform. But what is very cool about any of the current tooling and really CloudWatch and CloudWatch events is the ability to take all of that input and then trigger functions based on those events. So something like that GuardDuty finding, we had already had a function that would immediately remediate that. Now, there's already a terminate hook for CloudTrail for GuardDuty that allows us to natively terminate an instance that has exceeded a threshold, breached one of our kind of, I guess, thresholds for bad behavior. But what you can do, and kind of going back to, I think, Lars's conversation about the deployment pipeline, instead of just terminating the server, assuming that it's going to come back up in its auto-scaling group, we can trigger the deployment pipeline. We can also take that server out of the auto-scaling group and quarantine it, eliminate the egress-ingress security group rules. It's isolated, remove its EC2 instance policy, can't make any calls against the API, and that allows us to go and then investigate after the fact on our own time, where if we've, before, if you had seen the notification, it might have taken me 2-3 hours to maybe react to that email because I might not have seen it as such a serious threat that we wanted to immediately investigate and respond to it, much less take it out of the instance pool. Whereas if we already have automation wrapped around those events, and those events are categorized by severity, we can key into that and take more drastic action. Much higher severity levels, we'd probably immediately terminate servers or I guess throw caution to the wind and pull things out of rotation, whereas lower severity levels, sure, we might take a much more measured response and address it on our own time. So I think that's really what we see as the way to take the path, I think, with all of the data that's being generated in these in people's AWS environments. Sure, they have the tooling and all the data streams to pull all of this data together, aggregate it, put it into S3 buckets. But what happens is that there is really no way for anyone to have the bandwidth or the global expertise to respond to all of these in real time or near real time. Great. Thanks. And with that, we'll take any of your questions.
Any questions?
What is the time frame for, let's say, small SMB with 100 employees to migrate these workloads to the cloud?
So the question, let me see if I understand this correctly, is how long would it take to migrate hundreds of servers?
That's it.
Okay. From on-prem to the cloud.
With the entire education and handling the environment and the PCI compliance.
Well, that's an interesting question because some of our clients have gone ahead and sold the data center. So that changes the timeline. Others have roof leaks and the water's flowing in. So it's a tough question, but let's say the situation is ideal. It could be anywhere between 9 months and 18 months if all the kind of the patterns are followed. Okay, so let me see if I can understand that. So if you have a cloud-first strategy that's already developed, how long would it take to migrate from analysis to fully deployed into the cloud? Well, once you've done the analysis and you develop a schedule, you have to look at it more holistically than just one workload. But what you could start doing is, and there's different ways of lifting and shifting as well. If you want to do it from VMware to VMware on AWS, you can do it extremely quickly. If you want to go from an instance to an EC2, and you want to do all the dependencies, it also depends on are you going to refactor or you're going to redeploy your database, as an example. Are you going to move to RDS? You can do that very quickly as well. So there's not really one way or another, but once you start getting into the migration waves, they go very quickly. So doing all that groundwork up front is the most critical piece of understanding what you have and identifying those patterns. And once that transition, you get through that transition, that transformational phase, you can go very rapid. So you can start doing multiple in days. You can do them simultaneously. It depends. A lot of it's going to be QA as well, making sure that it works correctly once you get it there. You're going to want to go into what you call hypercare once you get it transformed as well. So that could be a 2 or 3 week period as well. So you want to add on that one?
Yeah, I think there's actually a white paper on secondwatch.com about this kind of migration that we've done in the past. And in this case, I think it was about 6 weeks. Mm-hmm. But that was after we already kind of identified the workloads and the strategy and things like that to migrate them. Because sometimes if you're just lifting and shifting, there's still a matter of either it's redeploy or just rehost. So there's other different methodologies that are kind of mixed in there too.
Lift and evolve.
Yeah, lift and evolve.
Yeah,
there's a whole bunch of them. But I would say straight lift and shift once you have the analysis done and all that stuff, because there's also things like service discovery that take a while. So if you use some type of network tracing tool that does service discovery to say what dependencies you have, that can take a while in and of itself depending on how big your infrastructure is. I think the one that we're talking about was 3,000, 4,000 instances. Yep. for that case study. So if you want to read that, it's on secondwatch.com. Yeah, that was the migration, and it was done in waves. So it was dependencies 1 through 5, and then dependencies 6 through 10 or whatever. It was done. Each wave was all of these systems have to move together because they all rely on each other. Whether it's databases, app front ends, I mean, there's still a matter of where I think we see it pretty frequently too. Like systems of engagement, like web front ends and things like that, are generally the first to move. And then you have systems of record, which have like PII data, things like that stay on-prem maybe a little bit longer and may get moved afterwards. And so you have lead times for like direct connect, or if you're just using VPN, you're gonna have like overhead, things like that. There's a bunch of other things to kind of think about when going into that. So like perfect scenario, everything, all that's already done, I would say 6 weeks.
Right, but the analysis phase being critical in order to plan and execute that in that tightest window possible.
Yeah, and that was part of the slides that you presented earlier. If you have that detailed plan, then yes, it can go very quickly, but you have to stick to that plan.
Yep.
It definitely can. If you're going, like, you're going to say, like, hey, I'm going to move all my systems of engagement to the cloud first, and I'm going to run all my databases on-prem. Yeah, you can definitely have performance overhead. I mean, that's just physics. It's like literally how fast light can travel. So.
Yeah. We got a question over here.
Oh, yeah. I mean, for discovery, I mean,
which ones have you used?
So we've used Cloudscape, and let's see, there's other ones for security discovery that might be in more of like the Palo Alto family, Evident and Redlock, was it Scout in the security side. But as far as, network discovery, Cloudscape is agent-based, but it can go in an appliance kind of fashion as well, losing a bit of the detail or granularity as far as how much it picks up off of each instance, the amount of detail there. But it'll oftentimes pick up network patterns, identify and make assessments. Okay, there's a bunch of 1433 traffic coming into this server. That looks like a SQL server just because of the way it's communicating, and then we can make judgments from there, and that really helps with extremely large scale data centers where we might not know exactly what we're looking at. Sure, it does. Yeah, so it'll provide all services that are running, utilization patterns, et cetera. So yeah, pretty much services running, port, protocol, destination, source destination, kind of the flow log type of traffic between servers, and then it'll try and create some sort of understanding as far as a relationship. These 20 nodes seem to be working together, and then you'll have to have some kind of human interaction to come along and say, yeah, that's correct. These ones are all part of this logical bundle that we reference as, scientific analytic one or something like that.
All right, right here.
At the start, you showed the chart that went up and then down and then back up again.
Yes.
And then the ideal chart that was up and then smooth across. Do you have experience with clients where they've started on that first chart and then come to you later and said, oh, how can we actually have gone down a bad path? And then do you recommend pulling them back and starting again, or do you sort of follow that path?
Yeah, I would say the majority of the time when we start engaging with clients, they've already started the process, and they're hitting that inflection point where the effectiveness is starting to diminish because of all the questions and uncertainty. It's very exciting getting going. You get a workload out there, it's great. Everybody has a lot of those aspirations and very motivated to get there. It becomes very confusing and arduous during that down phase, because you're like, how do I do this time and time again in a secured way? How do I meet those governance things? So it's so multi-dimensional at that point. That's where it can get very overwhelming, and that's typically where we get engaged, and because we've had a lot of experience in helping do that. So I wouldn't say it's an exact playbook for everybody, but ultimately what those high-level things that you need in there, they're all the same. It doesn't matter what industry you're in. Your compliance framework would change. If you're taking credit cards, of course, it's going to be PCI. You're in health, it's going to be HIPAA. But ultimately, if you really start digging in what those requirements are in governance and security, they're pretty much the same. It's encryption at rest, it's encryption at transport. All those things are pay for play. You have to do them anyways. So, but building that into the frameworks and the landing zone and that foundational component, and making sure that there's visibility to it to make sure that you're in compliance, that's where it becomes very. It's not, there's so many vectors into it and multidimensional aspects to it that that's when you have to kind of, it's good to go out and talk to somebody and say, what do we do? So, and learn from other experience, because that'll accelerate it. That's what we're trying to say, is not, you're going to get bogged down in those things, so how can I avoid that? It's to start that communication or that process earlier on and really kind of considering it, because the operational aspects are a whole nother category as well. How are you going to handle patching? Those types of things. So, I don't know, does that answer your question? Kind of?
Yeah.
Okay.
I'll just, I guess the other part is like, do you sort of go back and start from scratch and go, okay, the concepts are all good, but let's put them to the side now, or do you just sort of continue down?
Well, what we'll try to do is build in, no, we won't stop. We don't try to say crawl all the way back, but from the foundational components, let's take AWS config as an example. You can start using a lot of that data to go back and look at what's been deployed and say, does this meet compliance? And start layering in those additional layers to it and deploying them out there. The intention is to not say stop or rewind it and move back to on-prem. Yeah, but maybe take a pause, slow down just a little bit, but everything doesn't have to be done right away, but you have to really look and have that roadmap to make sure that you do have all those things in place over the long haul, because it's going to be critical for sustainability.
Well, I think that also there's like priorities within an organization, right? Like, what is the priority? Is the priority to lock down that environment and to visualize it and deal with all of your technical data up front? If so, I would say that's absolutely awesome. You should definitely do that. But like, when we talk about landing zone, part of that would also be like involving AWS organizations, right? And how do you provision new accounts, right? And this is something that we saw really early on when provisioning new accounts, like turning on CloudTrail and CloudWatch and config from day one to make sure that you can capture everything that happens inside that account. Because then you have a good reference point to say, like, from day zero, I know exactly what's been deployed in this. Now, what we could recommend a customer do, and I think we've done this maybe a couple times, but if they've had a POC, it's running, we've kind of like locked down an environment a little bit more, and then eventually move that environment into a new one that's been created from day one with all the proper like reference frameworks and things like that.
Mm-hmm. And that's a typical pattern as well.
Yeah. Did that answer your question? Yeah. Okay, great, cool. Any other questions?
Can you speak a little bit about the challenges and solutions around connectivity between cloud and on-premises?
Yeah. So the question is, just so it's recorded, is the challenges between hybrid connectivity between on-prem and the cloud during this transformation, correct? Well, yeah, there's a lot of challenges, of course, right? So it depends on a lot of the V's of your data as well, velocity and rate of change, those types of things as well, and how much data you're trying to move. And there are a lot of clients, it depends where they're located. If they're in a data center that it's easy to get to direct connect, great, it's a good way of doing it. And you can, but there's a period of time it takes to spin that up as well. And ultimately, you may not want to be in your own data center in the future, so you don't want to get locked into a long-term contract. But if you do need to move that large amount of data, sure, direct connect is good. You can lag the connections. You can get 40 gigabits if necessary. It's a lot of throughput, right? And then you have to look at Snowball, and we all want to play with Snowmobile, but that's not a reality for a lot of people, of course. But moving that large amount of data, if your intention is to not be in that hybrid environment, I would maybe say stay away from direct connect. You can use the public internet if you're in a good backbone provider and move a lot of the data that way. Your latency may change, your jitter on some of the packets, so those types of things can shift depending on the type of traffic that you're trying to work on. So I guess the bottom line is there's no right or wrong way. It really has to do with probably the amount of data that you're trying to move, latency. So because when you have a system of record still on-prem and you're trying to connect back from the cloud, how critical is that latency? That's where direct connect really comes into play. And if you're trying to move large amounts of data, of course, direct connect is a fantastic way of doing it if you need to do it, in kind of synchronously to some degree. If you can rely on moving large amounts of data in days, Snowmobile is a great way of doing it, or Snowball, excuse me, or multiple snowballs. That's something to definitely look at as well. It's an awesome device as well. But if you're trying to stay on-prem, you're always going to have an on-prem presence. That's a very typical pattern as well. Maybe you have a corporate WAN with comm hubs. direct connect is not a bad way to go.
And on the other side of that, if you're talking about like, connectivity between services, you can use something like Console from HashiCorp, use Console Connect to do service discovery between in the cloud and on-prem. So you can actually span data centers with a service mesh like that, which will give you some of that functionality to be able to at least reach back on-prem, and it gets around some things like overlapping CIDRs and stuff like that too. So it kind of gives you routes to that.
Yeah.
Yeah. One other aspect of that is, we just completed a migration of a large company, staying hybrid. And if you have a nice middle ground, still being able to get the direct connects but not having to rip up your, let's say, corporate backbone, would be if your provider has the capability to do like a VPLS where you can just break off direct connects at will. So AT&T has their NetBond product, which is really slick from a convenience standpoint, just because you can carve off or provision a direct connect from anywhere on that VPLS to the whatever VPC you want. So this helps in connecting a lot of remote offices directly, as opposed to having them go through a single one of their maybe 4 major regional data centers as kind of the choke point for all the smaller remote offices. If there is a remote office that has heavy utilization of the AWS resources, and it also allows them to get more of a multi-VPC, multi-account approach as well. So you can then provision multiple direct connects all off your same corporate backbone, going to all of your different accounts and VPCs across the globe.
All right. Well, thank you for your time. Hope you enjoyed reInvent.